welcome to this lecture. Hope you are understanding the concept of transformation and actions. In the previous lecture, we understood the definition of transformation and actions, and we saw a couple of examples as well. In this lecture, we are going to do a deep dive into that. We will understand what all functions are available in transformation and actions and try to understand them using an examples. We will categorize all the functions available into transformation and see which are complex one and which are in general which we use on a daily basis. Here is the list of all the operations available in the transformations. As I mentioned, we have categorized that into 4 different sections. First one is general, math and statistic, set theory, which is relational, and data structure. We are mainly going to discuss and examine the general purpose functions, which includes map, filter, flap map, group by, sort by key, reduce, collect, and so on and so forth. There are mathematical operations as well, but we are not going to cover those in the specific this lecture. We have a couple of more functions available in the general category as well, which is reduce by key locally, fold by key, aggregate by key, and combine by key. To deep dive into that further, we understood that there is a concept called narrow functions and a wide range of functions. Narrow transformations are those transformations where when we are converting the raw data to some specific RDD by applying some sort of transformation on top of that, shuffling is not happening. That is called a narrow transformation. Whereas in case of wide transformations, data shuffling are happening. Make sure that you understand this as a definition. We are going to deep dive into that in a bit later section. Again, narrow transformations are those transformations where shuffling are not happening over the nodes, whereas in case of wide transformations, shuffling are happening each partition ways. So give you an example, let's say your data is divided across 4 partitions in one single node. Now in that case, if you want to perform any operation which is a transformation operation, if the data which is presented into these 4 transformations, these 4 partitions are clubbed together or shuffled together to generate the output, is called as a wider transformation. Whereas in case of the shuffling is not required, and if it is handled at the local partition level, that is called as a narrow transformation. In narrow transformation, all the elements that are required to compute the record lives in a single partition. A limited subset of partition is used to calculate the result. Narrow transformations are the result of map and filter partitions. Whereas in case of wider transformation, in wide transformation, all the elements that are required to compute the records in the single partition may live in partitions of parent RDD. The partition may live in many partitions of the parent RDD. Wide transformations are the result of group by key or reduce by key. Let's understand what is narrow partition in more depth. As you can see here, each of the element of RDD is converted to the exact same number of RDD in the same partition. That is the perfect example of narrow partition. Each partition of the parent RDD is used by at most one partition of the child RDD. So map and filter are considered as a narrow partition. At this other side, when multiple childs of RDD partition may depend on a single parent RDD of partition, whereas in case of, let's say, group by key. So to give you an example, let's say you want to count the total number of present key across your file. So in general, you are performing a word count operation. In that case, your file is divided across 4 different partitions. There can be a possibility that the word which you are looking for to perform a count operation may reside in the same partition, and along with that some other remaining three partitions as well. So you need to scan all the 4 partitions to get the total number of count for the same number for the key. In that case, you need to perform a shuffle operation. So if you are looking for the word called as in key in one single partition, the word key can be also be present in the other 3 partitions. So you need to scan the current partition as well as the remaining 3 partitions to get the total number of count for the word key. That is why it is called as an wider transformation, where you are performing a shuffle operation and then at the end you are generating the count operation. Whereas in case of map or filter, what will happen is when you perform a filter operation, you are specifically saying that I want to filter the data from the specific partition, like the one which you are working on, and the same filter operation will be performed across all the 4 partitions. So you don't really need to shuffle the data to perform the filter operation, where filter operation will be performed locally on top of each partition. So that is called as a narrow partition. Let's revisit it one more time. If you want to perform any operation which incurs a shuffling between the data of partition, is considered as a wide partition, whereas in case of one single partition operation performed locally, that is considered as a narrow partitions. Narrow transformations. Now let's get started and try to understand the functions which we have available in each of the transformations. Let's start with the general purpose transformations. The first one which we are going to look is called as a map transformation. In map transformation, whatever RDD value you have, map will generate the same number of result with modified data which you explicitly mentioned to perform your logic. Map transformation is widely used to apply the transformation function on every element of the RDD or data frame and further returns a new RDD distributed dataset. So here, as you can see, we have 3 different elements present into RDD. Now when we apply a map function, Spark will take each of the element of the RDD and will try to convert that according to your business use case which you have implemented in your code. So the first one took and converted into your business case, same wise other one, and then the third one. This way you have given RDD X as an input, and after applying the transformation, map transformation has generated a new RDD which is RDD Y, which has the data with some new modifications applied to each of the element present into that RDD. Here, as you can see, after map transformation has applied, you can see 2 different RDDs, the RDD X which is in blue color and RDD Y which is in orange color. The denomination here meant that the raw data which was there in the RDD X is now transformed to data to RDD Y. Return a new RDD by applying a functions to each element of this RDD. Now if you see sort of example, how it look like is, let's say you have some example here and let's try to look into that. Let's try to understand the concept of map by looking at the pseudocode. Here we have 2 separate programming language pseudocode available. One is in Python and one is in Scala. What we are specifically doing here, that we are creating an RDD called X which contains an element called B, A and C, and then we explicitly called a map operation on top of the X RDD by saying that add one number for each of the key present into that RDD. Now when we performed an action which is x.collect, you will see the X has the older value available as in B, A and C, and when we perform the new RDD by saying y.collect, you can see the result in a different manner. Here we wanted to revisit 2 different concepts. The first one, if you remember, the first 2 lines are considered as in creation of an RDD. So in the line number 2, as you have seen that we have applied a map transformation which is resulting into one new RDD. So transformations are always generating a new RDD, and those transformations are only going to be executed when we are performing any specific action, which is you can see in the line number 3 and 4th. The same code is available in Scala as well, which is a simple pseudocode to make you understand how map partition work on each of the element of RDD. Now let's get back to our IDE and see the map transformation in action. We are back in our IDE. I have map transformation function already created to demonstrate you. In here, I am trying to read a CSV file which is present inside this path. Now what I have did is I am printing the schema as well as I am showing the data frame. Let me execute this first, and then I will explain you that how I implemented map function on top of it. So if we execute it, we can see the below output. Here the data is derived as in this schema where we have 5 different columns available: job role, company, location, job experience and skills. When we perform a show operation, the data frame got printed in nicely columnar tabular format. We have all the data available here, which is the first 20 line of my CSV. Now if we want to apply a map function, how we can do that? So here in the below code you can see a sample code written here. I will explain you this. So in this code, what I'm trying to explicitly do is I'm trying to merge the first 2 columns as a single column. I'm saying to Spark that club these 2 columns, which is job role and company, into one single column, and then 2 more columns will be presented here. One is location and one is job experience. See, as you can see, we are not considering the skill and description column as an output. So I want to perform my map operation on each of the element present here, which is in my output right now. So all in all, what I'm trying to do here is I'm saying Spark that Spark join these 2 first columns and make it into one single column, and then I also want location and job experience as well, but I don't really need skills for the output. So whenever you have a requirement to perform any operation on each of the object available, or I say record available to your RDD, in that case you have to perform our map operation. To explain you more about the code, the first thing which we need to do is we need to convert the data frame to an RDD to perform a map operation. So I have converted my data frame .rdd.map, and then I'm saying the data to be expected. I'm saying that get me each data and perform this operation on top of each data, and then convert it back again to a new data frame which is having this many columns. So my job role and company will club together and create one single column which is called as a row. Then I renamed my column location to a city and job experience as an experience only. I am not renaming it here, but I am trying to recreate the entire data to a new column. So this piece of code is called as an transformation. Why so? Because we are generating a new RDD out of it. But as a chain functionality, we have also implemented a action method, which is show method. What it is doing, that it will generate this new RDD, and at the end it is printing the data as well. So we are chaining the execution by adding the transformation as well as the action at the end. You can also separate this out by just removing this and creating a new data frame, or we can say map data frame, and you can perform the action on top of that. This is also acceptable. This is just for understanding. So now let's go back to our original code and try to execute that. Now let me revisit and let me re-execute the code. Remember that I have commented out the df.show, and as you can see here, the df.show in the previous execution printed this output where we are having 5 different columns, and all the columns are separated. The job role is having specific job role, company name is having IBM and Walmart, location, experience and skills. But now the new output which I'm looking for is I need a one single column for this one, and then this and this column. So there will be total of 3 columns, which is role, city and experience. Let's execute and see the difference. We have the output now. Let's check it out. Now as you can see here, the records, the schema got generated with the 5 different columns, which is specifically the column which we rendered from the CSV file, and then we ask to perform a map operation and make it into 3 different columns only. Now if we look at the output, we have 3 different columns. Role containing both the column in junction, the job role as well as the company. Let's see. Here we have a role which is, I guess, data science and then artificial intelligence, and then the company is also getting appended to the same column, separating by a comma. We have location and job experience as well, where we explicitly rename the column to city and experience. So likewise, I have implemented the map operation on top of the data frame by converting each and every single object of my RDD to a new RDD, which is the RDD got created in this place, and then we applied a specific action on top of it. Hope now you are clear with the understanding of transformation and action. Along with that, the very first transformation which we revisited today, which is map. Do let me know in the comment box if you have any questions, and I'm happy to help you out. Thank you so much for being on this lecture.